Hello, algebra students, Mr. Lawrence here, and we're going to learn about dilations, the last type of transformation we have to make sure we've mastered. Now, we're going to do two types of dilations. We're going to do one about the origin, and we're going to do one about a point. Okay? Now, about the origin is real simple. I'm going to get the points. Let's see, I've got point P, and it looks like it's at 1, 1. And I've got, I'll call that point Q. And Q is at 1, 4, I believe. Okay, we'll call this R. Sorry, I should be labeling them. R. And that's going to be about the point 1, 2, 3, 4, 4. And then S will be about 4, 1. Okay, there we go. Now, to do the dilation about the origin, I need to know my scale factor. That's by how much everything's going to change. This is so simple. All I'm going to do is multiply all my coordinates by 2, because my scale factor is 2. So the new P will be at 2, 2. There you go. The new Q will be at 2, 8. Right there, I believe. There's Q prime. Okay, P prime. All right, R prime will be at 8, 8. Which I believe will be right there. R prime. And then S prime, not Optimus prime, S prime will be at 8, 2. And there you go. I just dilated, which means to make bigger or smaller, this square about the origin using a scale factor of 2. Okay, now please use some intelligence here. I have a question for you. The original square, the length looks like it doubled, didn't it? It was 3 units long. It's 1, 2, 3, 4, 5, 6. And the width got twice as big. So I doubled the length and doubled the width. What happened to the area? I hope you realize it got 4 times bigger. It did not double. If you think it doubled, you should be able to take this square here. Let me see if I can get it to move all together. No, I didn't want the variable to move with it. All right. If you think it only doubled, and if I take this square, I should only fill up half. I should be filling up half of it, shouldn't I? Half of the big square. But if you look, I actually end up filling in. It won't let me color it. I fill in a quarter of it. So you see it got 4 times bigger. Oops. All right. Hold on one second. So here I made a copy of the square, and I put it in there, and sure enough, it fills up 1/4 of it. So if I double the length and double the width, the area gets 4 times larger. Okay, now there is another type of dilation, and that's when we do it about a point. In this case, I'm going to do it about point P, and that's the red point P. That's why it's in red when everything else is in green. And when I do that, point P doesn't move. And so it's 3 units this way, and the scale factor is 2, so it becomes 6 units. 1, 2, 3, 4, 5, 6. So there's the new S. Yeah, when I do it about the point P, the point P doesn't move, but the lengths and widths increase or decrease by the scale factor. 4, 6, I believe right there will be the new Q. Now to figure out the new R, I know it's a square, so I can just go right there. Alright, so the first type was a scale factor, a dilation about the origin, and the second one was a scale factor with, or excuse me, a dilation with P at the center. Okay, in one case the whole shape moves, in another case the shape just changes size. We're going to do one more, and that's going to be it for tonight's video. We're going to do this triangle. We're going to dilate it with a scale factor of 1/3, and we're going to start off by doing it about the origin. So first I need my coordinates. I got P, Q, and R. So point P is at 3, 3, I believe. Point Q is at 3, 9. And point R is at 9, 3. Okay, so the new points will be 1, 1. 1, 3. R will be 3, 1. How did I get that? Well, I multiplied 1/3 times 3. 1/3 times 3 is 1. 1/3 times 9 is 3. All I did was multiply the coordinates. So my new triangle becomes, the P prime becomes there. Q prime is at 1, 3. And then R prime is at 3, 1. And there is my new polygon, triangle specifically. Okay. Now, the area of the original, it got divided by 3 and divided by 3. So the area of the, or the length and width got divided by 3, or the base and height. So the new one, the area is 1/9 of the other one. How did I get 1/9? 1/3. Oops. 1/3 times 1/3. 1/9. So in other words, 9 of these triangles would fit inside of this big triangle. Okay, they would have the same area. All right, now if I'm going to do it about point P, well then I just see how long the segment is. P to R is 1, 2, 3, 4, 5, 6. 1/3 of 6 is 2. So the new one needs to be there. Okay. This is also 6 long, so that'll be 1/3 of 6. So it'll be 2. So the new Q will be there. And then you notice I actually get a congruent triangle. This little one and this little one are congruent to each other. It's just a different place. Why are they the same? Because I use the same scale factor. Had I used a different scale factor, they would be a different size. Okay, that's it for the video. We'll be doing dilations in class tomorrow. Have a good night, everybody.